Alright, let's go over example 3 of finding the maximum minimum value, the vertex, the axis symmetry, then domain and range of this quadratic equations. Now it is in standard form, so there are two ways to do it. In this video, I'm going to go ahead and do the first way by using this little formula called negative b over 2 times a. And negative b over 2 times a is actually the x-coordinate of the vertex. Well, it is the x-coordinate of vertex, but it is also the axis of symmetry. Okay, so what is our lowercase b and a value? Well, since it is in standard form, the lowercase a is the coefficient that goes with the highest variable, or the highest power variable, which is the leading coefficient in this case. So a equal to negative 5. B is going to be positive 10. So that means negative b over 2a is going to be equals to negative or positive 10, which is negative 10 over 2 times a, which is 2 times negative 5. Negative 10, well, let's say 2 times negative 5 is negative 10. Negative 10 divided by negative 10 is positive 1. So the x-coordinate of vertex is positive 1. Now, what about the y-coordinate of vertex? Well, the y-coordinate of the vertex can be found by taking the x-coordinate of vertex and you plug it back into the function. So that means, let's see, I'm going to call you my function f of x, okay? So f of x is this one. But if x equals to positive 1, then we replace all of the x with positive 1. Right. So let's see, 1 squared is just 1, and then 1 is just here. So negative 5 times 1 is negative 5. 10 times 1 is just 10. Negative 5 plus 10 is positive 5. Positive 5 minus 12 is going to be equal to negative 7. So the y-coordinate of vertex is going to be at negative 7. So the vertex h comma k equal positive 1 comma negative 7. Axis of symmetry is already positive 1, so we're good there. Okay. Now, is it a minimum or the maximum? Your leading coefficient is a negative number. So if you were to convert this standard form quadratic equation into vertex form by completing the square, which is what we are going to do in another video, you'll see that your function, your parabola that represents this function, is going to be reflected vertically due to the fact that within the vertex form, your function will be multiplying by a negative number, and most likely it is going to be this one. Because your leading coefficient is a negative number, well, in standard form, of course, you're going to have a maximum at the y-coordinate of vertex, which is negative 7. Now, what about your domain? Well, your domain can be found by one, graphing out the parabola that represents this function and read the x value from left to right and try to see if there's any point of discontinuity. If there's any point of discontinuity, you have to exclude that, using an open end of the interval. But algebraically, if we take a look at this function, we don't have any denominator. So that means we can take any x value from negative infinity to positive infinity, plug it into the function, and we'll be able to crank out the corresponding y value of each respective specific x values, okay? So the domain is actually go from negative infinity to positive infinity. Now, what about your range? Well, your range, you have to graph out your function. And let's just make a rough sketch right here, okay? So 1 here and negative 7 is down here. So rough sketch, your function is going to look something like this. And to find the range, all you have to do is that you read all of the y values from bottom to up. So your y value is going to go from negative infinity all the way to the maximum y value, which is negative 7. And since there's no point of discontinuity at y equal to negative 7, that means our range is going to look something like this, with the bracket at y equal to negative 7, because we're including that y value in there. We're not excluding it out. And yeah, that's how we find axis symmetry, vertex, maximum, minimum, and domain and range of this function.